Short queries often miss documents that use the wrong words. doc2query expands documents with likely query terms, so your Python search stack recalls more good results. This is the setup you'll be able to run after this, which adds likely query terms to documents and searches with a short query to recover missing matches. I'm Professor Pi, teaching search and IR with simple Python. Search often fails because users and authors use different words. A short user query can be perfectly reasonable and still miss the one document that actually answers it. Document expansion with doc2query attacks that gap by adding likely user queries into the document text at index time, so a simple lexical search can find more relevant hits. Think of it as writing a short set of question hints inside each document. Instead of changing the search engine, you enrich documents with phrases people would type. Success looks like higher recall for blunt or lay queries without rewriting your whole index or switching ranking models. At a high level, the idea is simple. For each document, generate plausible queries a user might ask about that document. Append those queries to the document text. A short search that previously missed the document now finds matching query terms inside the expanded text. Strengths are simplicity and compatibility with existing lexical stacks. Weaknesses are noise from bad generated queries and index size growth. We will build a tiny demo that shows the failure, simulates a generator producing lay queries, measures the before and after ranking, and then shows a safe two-stage re-rank that uses expansions only at re-rank time. This keeps the code and the concepts compact, so you can later scale them. Now we run a tiny lexical search to show the problem. This snippet runs a minimal lexical search to show how a short query can miss the right document. The function talk lowercases and splits text into simple tokens, removing trivial punctuation. The variable docs holds 3 quick domain-diverse documents, and Q is a deliberately short lay phrase query. The set QSet captures the unique query terms, and the function S counts how many of those terms appear in a document text. We sort documents by this count, breaking ties with the identifier for stability. The printed top document and its score reveal that the kidney care document wins because it matches care, while the heart attack article is missed entirely. Next, we will simulate generating likely user queries from documents. This example simulates doc2query by generating likely user queries from each document via a compact phrase-to-query map. The dictionary maps expert phrases to lay queries, capturing the idea that a generator proposes queries users might ask. We save base docs as an unexpanded copy for later comparison. The function expand scans a document's text and emits all mapped queries when their source phrases are present. We build exp, a per document expansion string, then append it to each document's text to emulate index time document expansion. The printed expansion for the cardiology document shows lay phrases added that short queries often contain, setting up improved recall. Now we compare ranks before and after adding those generated queries. This code compares top 1 accuracy before and after doc2query style expansion. The function rank orders any document set using the earlier S function, which counts overlap with the short query. We evaluate top 0 on base docs, no expansion, and top 1 on the expanded docs to see whether the correct cardiology document rises to rank 1. The integers hit 0 and hit 1 mark whether the top result matches the known relevant identifier D1. By printing before and after, we directly observe the effect of adding likely query terms into documents. The result shows a jump from miss to hit, demonstrating restored recall at rank 1. Next, we will add a simple weight to control how much generated text matters. This snippet introduces an expansion weight alpha to balance base text matches against doc2query terms. The function sBoost computes the base overlap from the original document and the extra overlap from the generated expansion, then combines them as base plus alpha times extra. We pull the cardiology document from base docs to isolate scoring without side effects. Computing with alpha values 0.5 and 2.0 shows how the expansion's contribution scales smoothly. Larger alpha emphasizes generated queries and can help more when the base text lacks lay terms. Smaller alpha is safer when expansions are noisy. The printed scores quantify that scaling, clarifying the practical tuning trade-off. Finally, we will show a two-stage pipeline that only re-ranks top candidates. This example builds a tiny two-stage pipeline. Retrieve candidates with a lexical pass, then re-rank them using doc2query matches. The list, canned, holds the top 2 documents from the base index using pure lexical overlap with the short query. The function sc2 combines base overlap and expansion overlap, scaled by alpha, mirroring a fusion of original content and generated queries. We re-rank only the candidates, which keeps latency low while letting expansions flip close decisions. The printed top identifier shows the cardiology document surfacing after re-ranking, demonstrating a compact, practical baseline that improves recall for underspecified queries without rebuilding the entire index. In a real system, you would replace the phrase map with a trained generative model that proposes many queries per document. You would also store expansions separately or compress them so index growth stays manageable. The two-stage approach scales well because it avoids re-ranking the full corpus. Recap. Document expansion with doc2query means appending likely user queries to documents, so lexical search finds more matches. Use it when users write short or lay queries and recall is low. Caveat. Generated queries can add noise and increase index size, so tune and validate. Next step. Tune the expansion weight and candidate count in a two-stage pipeline to find the best balance between noise and recall. If short, practical IR helps, subscribe and watch the IR videos.